Greetings, everyone. Um, this is exploration of how we might work together. On this, let me just say this is a fantastic opportunity we're really excited about and want to embrace. And I think something which we've been interested in for a while is thinking about scaling up how we could apply permaculture methodology in thinking on a slightly wider scale, on a bigger scale. And all along from the outset, we've realized that the most powerful thing that we can do is to create working models, is to create examples that we can learn from, templates that we can learn from. Yeah, so thank you for this opportunity, and I want to find ways in which we can have really useful and informed conversations about this approach and what we're doing. Wow. This is the Google Maps picture of Kumi Hospital and the surrounding land. Gives me an impression of the scale and the challenge / opportunity and what we've got there. I'm seeing really quite relatively. I have been there once, but yeah, relatively flat and extensive. So the first thing to say is the permaculture approach is to start small with small and slow solutions. Start small, create a model of what we intend to do, and scale it up. And we're very much also interested in kind of incremental design, step-by-step approach. It's kind of a bootstrapping approach. And we also think about sort of succession, about what would the sequence of how we might approach this. So sort of capacity building, building nurseries, propagating plants, identifying stakeholders, trainees, volunteers, and understanding that how we can build teams to work on this. And so when I look down and I see this, I understand 500 hectares ultimately of land, which is a lot. We're obviously not going to just run headlong into that, but we're going to build hubs and build areas that we can build out from. I think several members actually of the Sector 39 East Uganda UPO team came to visit you in March 22. As I remember, it was before the rains, and the site did look sort of dusty and dry. So that sort of maybe exaggerated my impression of the challenge that we face there. Yeah, just looking down at the grasses that you'd introduced and seeing sort of bald patches everywhere, that kind of sets off alarm bells or warning signs that are to say of a system that is not flourishing, shall we say, and we could really build on. And again, it's a big site. It's an open site. There's settlement beyond it. So we also maybe saw advantages and potentials of engaging with that surrounding community and also sort of educating them and informing them of the techniques, the approaches, the kind of methodology that we are using, because in our experience we find these ideas translate out actually very readily, and having a engaged and supportive community around could really further the sort of long-term benefits of this system. So yeah, just some basic assumptions from what you've told us and what we've picked up, that there's something like 500 hectares of land there surrounding the hospital. It's a Dutch charity that owns it. It's been a quite intensive dairy farm, I think, since the 50s and 60s, I've been told, maybe up to 1,000 head of cattle. And over time, we've seen that the soils have become somewhat depleted. There's been attempts to improve and revitalize, and I think the sort of a cost-benefit analysis of that has led the Kumi hospital team to look at other opportunities. And as I understand it, there's now a commitment to explore the potential of a land rejuvenation plan using a permaculture methodology approach. And I think that's a very exciting opportunity to to turn things around. And depending on, this doesn't have to cost lots of money, but it might take time. There's a time-money relationship, and but this is highly doable. So, inspirational quote. It's all about soil, and if we lose our soil, we degrade our soils. We really are destroying ourselves. Obvious to say, perhaps, but actually, I think we're always focused on the output, on the cattle, on the process, the milk, whatever, the output, rather than actually the system itself. And it's underpinned by healthy soil. So, what do we mean by healthy soil? Well, soil is alive. Let's if we're going down the permaculture approach, which is what you have to do, is you have to understand that only an organic approach is acceptable, for long-term soil health. And anything else is going to have a long, erosive impact over time. So stewardship under a permaculture approach focuses on developing and optimizing the life in the soil. The minerals that we need to grow healthy pasture and grazing systems to support your cattle, the minerals that you need are there in your soil. What will have become depleted over time is the soil biota, the life in the soil, and it's the action of that life in the soil that makes those minerals available to the plants. And this is sort of central now to the understanding in how soil biology works. So healthy topsoil, it's an open, friable, aerobic, living thing. It shouldn't ever be, once it becomes hard, compacted and dried out, then the life in the soil then dies away. And that's the problem ultimately that we're addressing. Healthy soils have 5 trophic levels in abundance, and to bring back the life in the soil is our goal. So trophic levels, energy levels, think sort of pyramids. The only new energy coming into any system is coming from the sun. Plants translate that energy into sugars and carbohydrates through photosynthesis. So clearly the greatest amount of biomass in the system is the plant level, because that's the primary or first trophic level. Now, what's now fully understood is as plants become established, they use increasingly, they push increasing proportions of the sugars created through photosynthesis down into their roots. And they give off these sugars as exudates, which feed beneficial organisms, fungi, bacteria. So that brings us into the second trophic level, and there's some very intimate and essential relationships going on within the soil at this level. Plants form mycorrhizal associations, mycor meaning fungi and rhizae meaning roots. And these root fungi relationships turn out to be absolutely key to the sort of long-term health viability of living systems. And within the fungal hyphae creates pockets where many other organisms can live, and might be a mixture of decomposing mutualists, so these sort of beneficial organisms that break down dead organic matter, and again, building soil humus, making nutrients available to plants. And then there's also potential pathogens and parasites, sort of bad things, and root-feeding nematodes. What we know is good soil management promotes the beneficial organisms, and a good mycorrhizal fungal establishment. So to establish good soil life, you have to be organic and you have to minimize tillage, because when you do any form of tillage, you disrupt the mycorrhizal fungi, and they turn out to be the sort of the building block of long-term soil health. Um, so then there's a third trophic level um, of all kinds of protozoa, things like amoebas and ciliates and things that feed on the bacteria, and nematodes, worms that feed on the fungi and bacteria, and microarthropods that maybe shred organic matter, accelerate decomposition, and also interact with fungi and nematodes, and feed at this level of the root system. It's only when we get to the fourth or fifth trophic levels that we start to actually be able to see what's going on. We see larger arthropods, larger nematodes and worms, the kinds of things that we associate with healthy soil. But for sure, they're sitting on the sort of the top of a pyramid of many other invisible microorganisms. And our strategy is to bring our whole soil food web back to life, back to abundance. And that's the basis of how we will rebuild the fertility at Kumi Hospital. So there's a global movement initiated by Dr. Elaine Ingram, who is, when I was at university studying ecology and sustainable development in the 80s, I was told, what goes on in the soil is so complicated. In that first 2-3 inches of topsoil, it's so complicated that we don't really understand it. Science can't describe what's going on because there's so many different interactions. Well, that was 30 years ago. And in that time, people like Dr. Elaine Ingram have studied soil science and made this information now available, and to think about how our understanding of the living soil, the soil food web, how we can bring that now into our sort of cultivation techniques, and how we can work with it in a very positive way. So this is also a chance to be part of something like that's global, and that's a big part of our climate change response and food security response. So this is a great opportunity. So what we're going to do, what we're here to do, is to rebuild soil. And as we rebuild soil, we'll create numerous other opportunities to diversify and strengthen the landscape at Kumi Hospital. So let me just I thought I'd give a quick sort of tour of the elements, of the components perhaps of our strategy. And obviously later on we'll have to think about how we would assemble these together to make like an action plan. But let's just think about this. We need to capture and hold every drop of rainfall that falls on the land at Kumi Hospital. And by that we mean we need to encourage it to infiltrate into the ground. We need to soak it into the ground. We want to eliminate any kind of surface flow when we have heavy rainfall. And we'll do that by developing over time a swale-based catchment system. These are ditches and banks that always lie on contour. The purpose is to promote the infiltration of water into the ground, never for it to flow. Moving water can cause erosion, obviously carry soil with it. So as you develop your swale system, it will have a long-term, permanent, cumulative impact on the landscape. So this is it, because it only is working through gravity. Rainfall comes out of the sky, hits the ground, tries to run downhill, and then infiltrates into the soil and becomes part of the soil ecology. So these swale lines offer amazing opportunities for strategic plantings, because on the lower slopes of them are going to be marginally moister than the surrounding areas. So we can establish soil building trees. shade-giving trees, beneficial trees, other fodder trees, fruiting trees. Once we started this process, we have the opportunity to select and add to it continuously. So all of this in turn boosts the yields. It builds soils and increases shading and reduces evaporation. So we're putting in place a step-by-step approach with a series of investments which are going to maximize retention of rainfall. So if we look at a cross-section of what a swale might look like, and surface water is always going to flow downhill. It's very easy to predict where that's going to go, and we can we can excavate a ditch and use the soil that we've removed to create a berm or a bank on the lower slope, so that rainfall will sit in the swale trench and have more time, more opportunity to percolate into the ground. Where once water's in the ground, it stays there for a long time, and we can design and develop guilds, combinations of plants which can maximize the use of the benefit caused by the swale, and also serve other functions: shading, fodder, soil building, deep roots, etc. And if you imagine your contour, your swale is going to follow your contour, so you might get an undulating but still a linear path across your landscape, which is level, and then that gives us a chance to plant along those lines and boost in a way which will boost the whole system. Now, this is just a library picture from the internet, but imagine how over time this might then change the shape and the function of the farm, and add layers of different opportunities. So we're seeing these shapes because we're following the contours. We've got rid of erosion, and we're catching and holding on to as much rainfall as we possibly can. And obviously the joy of the system, people might say, well, how big do you make the swale? How wide? How many do you need? What's the gap between them? Well, the answer would be, it depends, because it depends on the pattern of rainfall. And if we're getting a very heavy, intense rainfall in a short period of time, we need to make the swales wider and deeper. And if the land is where it's steeper, they need to be closer together, and where it's flat, they can be quite far apart. So it depends. And the approach to doing this would be to start off in some place or places, and then observe when the rain comes how the system works. So we sort of, as we implement it slowly, we also learning about how the size and the Another element, once we start to introduce all of our swales and start growing all of these extra trees and plants and shrubs, we're going to have a lot more biomass. We're going to have a lot more materials that's grown that potentially we could pyrolyze into biochar. Biochar being charcoal, but let's imagine it more in a dust form, or made from crop residues and say a narrow diameter wood that we've harvested, or something like that. And the end use of this biochar is not as a fuel. We don't want to burn it. We want to incorporate it into the soil. We're looking here at a scanning electron micrograph picture of biochar at a high magnification. And what we're seeing is it's made of tiny pores. It has a huge surface area. In fact, a teaspoon or a spoonful of crushed biochar might have a surface area of a hectare. I mean, it's and that obviously creates opportunity for soil microbes. It creates habitat for those soil microbes. It folds air into the soils, and increases the porosity for water, for water absorption and water holding. So, and really interestingly, is you can crush up biochar, feed it to cattle, and as a result of it passing through their gut, they get a more efficient feed to protein energy conversion rate, because it helps the fermentation and digestion of their food. It reduces the amount of methane that cows produce, and then ultimately it gives us a bio-inoculated material when it comes out the back end of the cow that can be directed to the priority areas of the farm, perhaps where we want to have focus of fertility. But in general, it's going to have a long-term impact on the whole wider sphere. So we can increase the nutrition of the cows, and then we can also use the cows as a method to disperse our biochar. Mycorrhizal fungi. Plant roots have very strong associations with specific beneficial fungi, and that expands the surface area of the plant by many times, 1,000 times. And it if you imagine the roots of like the motorway system, and the mycorrhizal system is that all the B roads and the little tiny little roads reach out into all the nooks and crannies. So plants can grow without mycorrhizal fungi, but they're greatly reduced. We're missing out on a massive opportunity here. And let's be clear, mycorrhizal fungi are very readily affected by fertilizers, by tillage. So we're looking at a minimum or a zero tillage system. We're really doubling down on our organic sort of commitments, because we can quickly break down. This is how we've gotten into this sort of challenge. Maybe is not allowing these processes to optimize. A big component that comes from Dr. Elaine Ingram is, question is, how do we get our, if we've got to sort of promote our beneficial soil microorganisms, and what we're going to do that through compost. How much compost do we need for 500 hectares? It's a lot. That's obviously a prohibitively large amount of material, and then that in itself becomes kind of logistically challenging. What has come from the Soil Food Web project is that if we make good compost, and it has those four layers of beneficial microbes, soil biota, in our compost, then we can actually wash those beneficial organisms out of the compost into a large vessel of water, and by bubbling air through it, we can multiply those organisms. So the realization, the learning has been, we don't need hundreds of tons of compost to put on the land. What we just need to do is to have batches of compost and then multiply the beneficial microbes. So there's a focus on these we're talking aerobic microbes. So we need to make good quality aerobic compost with elements coming into it from many different sources to give us a wide microbial population. And then once we've done our composting process, we can then multiply those beneficial organisms in compost teas and then apply them directly to the land. And of course, the benefit of this, the beauty of this, is we can quickly observe with our eyes. We can see the impacts that this might have, and we'll work on different areas. Combining these techniques together, and we're also very interested in combining compost tea with biochar as well, and inoculating the biochar through composting processes. So lots to learn. As we introduce our swale systems and we try to diversify the plants there, we're going to be looking at different. So in permaculture, really interested in identifying plants that serve multiple functions. So, for example, trees that also fix nitrogen. trees that create good habitat, trees that could also provide field boundaries and edges, trees that are easy to propagate, trees that are really good for wildlife and biodiversity, birds and other insects. Because remember, we want all 5 layers of our trophic pyramid to be to be there and to be healthy. So we can add elements into the farming system that support every layer of that. Of course, the cows and the grazing is our ultimate goal, but to achieve that and to optimize that, we need to build the whole soil ecosystem. So lots of local and indigenous native plants that we could explore to put into along our linear swale plantings. And then there's all sorts of amazing, really fast growing, I don't know, sort of mimosoid family, again, nitrogen fixers, rapid growing. I think the Lucina tree, Lucina, is it? It's the fastest growing tree in the world. So again, think about, we could do that with for biomass, for biochar, and so forth, and translating the energy of the sun into the soil through plants, and remembering that our linear plantings of trees will latch onto mycorrhizal fungi, which will then distribute those nutrients across the whole pastures. There's lots. I mean, certainly. Then once we think about these kind of plantings, we can think, the magic of moringa. Amazing, another nitrogen-fixing tree. It's very protein-rich leaves, many medicinal uses. Definitely worth propagating, and really interesting to think about how we could integrate that into our sustainable grazing scheme. Vetiver's another one that's really interesting. We can have living hedges made out of plants like Calliandra, and we can explore many kinds of ground cover plants and herbaceous plants, which might add also and diversify the yield from the system. So we'll definitely be looking to use these really deep-rooted plants, such as vetiver, which gives us a biomass yield. It gives us actually an essential oil, but it has a massive root system. It's very, very drought tolerant once established, and its massive root system will open up compacted soils and feed and benefit, many microbes. And it's a very adaptive plant, even in dry lands, and can withstand flooding. So you can plant vetiver plant. It's a clumping grass. Okay, so it doesn't spread, it doesn't set seed, but it forms clumps. So what you do is you can let it form a clump over a season or 2 or 3, and dig it up, and then break it up into plantlets. And then you can put those plantlets in lines along contours, and they have that same soil stabilizing effect and water percolation effect that we've been talking about in terms of swales. The next thing we can understand, the element we can bring into it, is to this idea of cell grazing or mob grazing, managed grazing. So the principle is to concentrate the animals together, as they would perhaps naturally, and fully graze a segment of the land before then allowing them to move on. And this has multiple beneficial effects. It's more efficient for grazing. It delivers all the animal manure and into one place. The action of the hooves on the soil mean that those nutrients are retained and again infiltrated into the soils. And the voracious grazing, intensive grazing of the cattle, encourages the grazed plants to shed root matter, which over time builds soil carbon. And then obviously we cycle the animals around the farm and don't bring them back onto a cell until it's fully recovered. So as we start to develop and put these things into place, we can offer training and support. It's not just the skills of how to do it, it's the knowledge of why we're doing it. And we use the permaculture ideas, the permaculture methodology to help people understand these processes, and so that they can feel that they're part of teams, um, and can engage and make decisions with managing and developing the system itself, and then through that give us feedback, monitoring, evaluation, you know, all the time. We need to be able to understand as this unfolds, and then anyone that we're working with through this is going to share that knowledge with the people around them. And we found that permaculture knowledge travels well in a sort of peer-to-peer learning environment. So we would see the planning, the development, and execution of this design project as a training opportunity, as an engagement opportunity to reach out to surrounding communities. So we would train our own team members and team leaders at the beginning of the process, look to volunteers, helpers, and staff, and clearly the staff, the stakeholders, the surrounding community, Kumi Hospital, will rapidly be brought into understanding how we're going to slowly unfold a series of strategies which is going to catch and store water, build soil carbon, build soil fertility, and ultimately give us much more diversity of yields and so many other unexpected outputs that we'd get from working together and learning together and this diversification. We would build into it an ongoing monitoring and evaluation process. So everyone who's engaged with the project would have an ability to feedback their own experiences, and we'd also do testing. We can test the grasses, we can see the nutrient density and quality in those grasses, and we can look at obviously the yields of the milk and other things, and have a sense of the progress of the project. And this would be very, very important data for us. We are part of other networks, and what we're doing here will be of interest to other people, and obviously other people are doing similar experiments, and we can learn from them. And there's a real value in us documenting this process, treating it, creating it as a case study, and then sharing these outputs, because I think the world is waking up that this is a sort of a toolbox of approaches now that we could be using in land landscape rehabilitation. That's the word I'm looking for. Yep, there we go. Thank you very much. Those are my initial ideas, and we will hopefully build on that and the feedback from you. Thank you.